Hi, my name is Shakiba, and I'm a member of 3DI Lab at Virginia Tech, and I will present our work on integrating everyday proxy objects in multisensory virtual reality storytelling. Virtual reality can be defined as an interactive and immersive experience in a simulated world. Physical proxy objects provide shape, weight, and texture stimuli in VR. And so they're a low-cost and powerful way to enrich the user's multisensory feedback, which will improve their sense of presence and immersion and the interactivity of the VR experience. In this work, we designed a 3D user interface for a VR escape room experience. We use different techniques and components in this experience to improve its immersion and interactivity. The main technique we used for this purpose was to create storytelling. For example, for interactive proxy objects, tracking each one of these physical props is a critical challenge. When multiple props are used, having one tracker for each prop can be expensive. Plus, many of these props are only interacted with for a short time. To tackle this challenge, in our storytelling, we introduced the tracker to our users as a temporal stabilizer. In the story, the temporal stabilizer is defined as a device that should be attached to each object in order to make it interactable. Introducing this notion to the story allowed us to track all of our proxies using only one tracker without disrupting the user's feeling of presence. There were, however, challenges when designing and integrating the stabilizer into our experience. One of these challenges was that the user frequently needs to detach and attach the stabilizer. So the challenge was to make the stabilizer easily detachable, but also be able to precisely and firmly attach it to the physical proxies. And we say precisely because for some of these props, the orientation of the tracker relative to the proxy was important to us. So to resolve this issue, we used magnets. So the magnetic field would force the correct orientational alignment of the tracker on the physical proxies. There were some considerations when designing the physical proxies themselves as well. One such consideration was the reuse of the same proxies. Unlike active haptics, here for passive haptics, we need one proxy for every single interactable object on the scene, which for a big experiment like escape room can be too many. So we thought, since passive haptics allows us to build real-world proxies based on virtual objects, why not design different virtual objects that are similar in shape so that we can reuse the same physical proxy for them? So for a few of the objects on the scene, our virtual design was adjusted to accommodate reuse of the same physical proxies. You can also use these physical everyday proxies and augment them with other components to enhance the affordance of the interactions. For example, material with different textures can be used to customize the tactile feedback. We augmented everyday proxies like a plastic bottle and a swim noodle with some low-cost electronic components to enable squeezing interaction. So the user could adjust the fire volume of the blowtorch by adjusting the force of squeezing the swim noodle. Overall, our design incorporated physical proxies into the UI to offer an immersive high-fidelity experience while overcoming various VR limitations.